Kia ora, 12 MCA and 13 MCA people who are resitting. This is a sequences problem for Minduk, which is really nice, especially the second part. Remember that when you're doing sequences work for AS questions, there are basically only two things you have to choose between: an arithmetic or a geometric progression. And then you can either be finding individual terms or you can be finding the sum of n terms, or in the case of a geometric progression, you might be finding the sum to infinity, which is S to infinity is equal to A over 1 minus R. We're going to use this one in this very straightforward first part. So the muckier part of this question, which is what Minduk wanted me to video, was this bit down here. So let's have a look at what we've got. Okay, the first part, we've got a geometric progression, and we're told that the second term is equal to 24% of the sum to infinity. Figure out the possible values of the common ratio. And then the second part is completely separate. We've got two different arithmetic progressions. So the first one, P, has got first term of A and a common difference of D. And then the second one, which is Q, has got this first term and this common difference. And we're told that we've got a ratio of terms here and we've got a ratio of the sum of terms. So I actually find these questions usually pretty boring, and this one's no exception. All we're really doing is we're going to be applying in this half, we're going to be working with the sum to n terms formula, which is this one here. And in this half of the question, we're going to be working with this. And you should be able to see that we've got two things. We've got two missing bits of information, which are A and D. So we're going to do a little bit of boring simultaneous equations work. So you just have to be careful not to muck the Year 10 algebra up along the way. So first I'm going to do part, what am I going to do first? Part A, because it comes first. So we've got a GP, and we're told that the second term is 24% of the sum to infinity. So in a geometric progression, the first term is A, and then we've got A times the common ratio, and so on. What we know here is that the second term will be AR, and we know that it's equal to 24% of the sum to infinity, which is A over 1 minus R. Now, we know that A is not 0. If it were 0, then the sequence would just be 0, 0, 0, 0, 0, so it's not going to be that. That means that we can divide both sides by R. So R is equal to 24 over 100 times 1 over 1 minus R. And this simplifies to give me 6 over 25. Right, multiplying through, I get 25R times 1 minus R is equal to 6, which is a quadratic. 25R minus 25R squared is equal to 6. Taking everything to one side gives me 0 is equal to 25R squared minus 25R plus 6. So it's going to have the following pattern. Remember that in the Cambridge exams, you must show evidence of your solving of quadratics. You cannot just jump straight from here to the answers, no matter what a child prodigy you are. I don't want to see that. So we want to see some factorising. Let's just try 5R and 5R. We know that we've got to have two subtractions, and we need two numbers that times to give me 6. So let's try 3 and 2. Hopefully you guys can see that pretty quickly as well. Remember, the way to do it if you can't see that is to do the grouping method here. We want two numbers that times to give me 150, and we want two numbers that add to give me a gap of 25, and so on. But 2 days before the exam, by now all of you should be very, very good at factorising quadratics like this one. If you're not, go watch the Year 12 video on it. So the last step here is to say that 5R equals 2 or 5R equals 3. So R is equal to 2/5, or from this one, 3/5. So that's that question done. Okay, now on to the muckier one. We just have to go slowly. Right, so I'm going to clean up some of this. And we're going to work out what we can say. We've got 4 things that we've got to set up, right? So when I started out doing this question, I just noted down, what do I know for arithmetic progression P? Well, we've got A and we've got D. And then for Q, the first term is 2 times A plus 1. And the difference is D plus 1. So let's play with this one first. The fifth term of P, I'm going to write as U5 with a little p. And that's equal to, the formula is A plus n minus 1 times D. So that gives me A plus 4D. That's that one. Now I'm going to do the 12th term from Q. So U12 from Q is going to be the first term, which is 2 times A plus 1. Right, so I'm working with this sequence now, plus 11, for n minus 1, 11 times D plus 1. Right, so let's clean that up, expand out the brackets and collect up like terms. That gives me 2A plus 2 plus 11D plus 11. And I know that the ratio of those two things is equal to 1/3. So I've got 1/3 is equal to A plus 4D over 2A plus 11D plus 13. Cross multiplying and then collecting like terms gives us 2A plus 11D plus 13 is equal to 3A plus 12D, right? Just timesing that by 3. I'm going to bring everything over to this side and I'll get 0. Oh no, I'll leave my numbers here. I've only got 1. So 13 is equal to A plus D. So that's what I get there. Now we've got to go and do the same painful thing on the other side, but this time it's going to be with the sum to n terms. And the sum to n terms is S of n is equal to 1/2 n times 2a plus n minus 1d. So the first 5 terms of P, S5 of P, is going to give me 1/2 times 5. And I've got just an A and D for my things in here. So it's going to be 2A plus 4D. That simplifies quite nicely. That gives me 5A plus 5 times 4 over 2 gives me 10. 5A plus 10D. So that's that one done. Now we'll do the same thing with Q. It is worth quite a lot of marks, but I'm not particularly enjoying this. I mean, it's still maths, but it's not fun maths, right? So 5 over 2 times what? Well, this time we want 2a here. So a is this. So it's going to be 4 times a plus 1 plus n minus 1 is, am I doing 4? Yeah, that's right. Plus 4 times the common difference, which is d plus 1. So this cleans up to give me 10 times a plus 1 plus 10 times d plus 1, which is 10a plus 10d plus 20. And now we know the ratio of those two things is 2/3. That's going to get me my second equation. So 5a, where's it gone? 5a plus 10d over this one, 10a plus 10d plus 20 must equal 2/3. There's a common factor in there of 5. So a plus 2d over 2a plus 2d plus 4 is equal to 2/3. 3 times a plus 2d. I bet there's no one watching by now. Maybe there are still some year 11s watching. Are you watching? I don't know. 3a plus 6d is equal to 4a plus 4d plus 8. Right, -8. I'm getting this in the same format as the other one, is equal to a minus 2d. We're going to take that and we're going to put it together with this one here. So -8 is equal to a minus 2d. Right, I'm going to label those equations 1 and 2. And I'm going to do equation 1, take away equation 2. And I'll get 13 minus -8 is 21. And then d minus, sorry, that's not an equal sign, that is minus sign. D minus -2d gives me 3d. So I'm subtracting all of that. So d is 7, and that means that a has to be 6. And there we go. I used that to get that. And if you check that all on the mark schedule, that is the right answer, and you get your full marks. And OneNote has just shut down, so I will hang up the video software.